Welcome back to the channel. In this video I'm going to be talking about this interactive LED clock that I developed using hexagons, where you can interact with it, you can press any of the hexagons, and it always also functions as a digital clock. And I'll be going and talking about some of the new features and then a little bit about the coding that I have developed as well. So when you first plug it in, it's going to show the flowers, and you have a little bee that is going to flutter up and down. The flowers go, and if you click on the bee right here, he's going to go to a specific location, and then if I click anywhere else, the bee will follow and go to the point that I clicked. So this clock is it has a display. It's like a touch screen display, and so you can interact. You could actually make a Pong game, and you could have an object bouncing back. There's many different features that you could program into this clock. The features that I programmed are this bee, and then if I just click on the bee again, he's going to go into the flutter mode, and he's just going to go up and down. And now if I click anywhere else, it just displays the time. If I don't, and it'll just flash and it'll go back to its normal mode. So this is mode 0, and if I click on the top button, this display will get brighter. And this button right here, it gets dimmer. So at night time you can make the display brighter or dimmer. The third button is the mode. So this is the clock mode. Okay, it's just going to just show the clock with a background color that you can customize just by clicking anywhere on that. And if you click on the red dots in the middle, they turn red. That means it's going to change the time mode. And you can click on any of the digits to change the time. So right now it's 11, so I'm just going to turn it back to 11 o'clock. And then when you're done changing the time, you just click on those two dots in the middle, and then it goes back to the time mode. And if I click on any of the digits, you can change its color there, and then you can get any kind of effect that you like. Now, after the time mode, below that, the fourth button, this is called the background. Okay? So if I click on the background, instead of having it filled, this is called a gradient background. And so you can see that now the background is brighter at the bottom, and then as it goes up, it gets darker. And then if I hit the background mode again, this is a fading gradient. Okay, that means that it's going to get brighter, and then it's going to get dimmer, and that could simulate like a pulsating heart that's alive. And at nighttime, it would really glow, really nice. And it's the hexagons is a really good shape to make it look more modern. And if I click this again, what this is a gradient background, and it's going to randomly choose a color, and then it will display that. So this is just a gradient color that it's going to change. If I change the other background, I have a rainbow effect, and that's just basically a rainbow. It's using a sinusoidal wave and it's going on an angle, just kind of showing a pattern of the rainbow effect using the RGB lights in the inside. And if I go back, this is the basic mode. It has no background at all. That's the last mode. So those are the different modes here. And if I click on the last mode, this is the drawing mode, where it just has a fixed background color that you can change. And if you click on any of these buttons, you can draw a picture where this will just change any color that you want. So you can draw a picture and so on. If you want to erase it, you can just hit the erase button. If you want to change the color, just hold on the erase button. And if you don't want to have a fixed background color, like this is a bluish background color, right? You can hit the last button and the last button will clear the screen where it's just a solid no color, like that. Hit the mode button, will go back to its basic mode. It's an interesting design where I didn't cut the LED strip. It's just a continuous strip that just zigzags in the back, just using one Arduino there and a timing chip. The electronics are pretty basic, and the unique feature is I'm using just one row of resistors. The LED strip goes up and down, but I detect them in a zigzag pattern because they're all pulling off one single resistor to save components. And so I have to program it to figure out exactly where you're pressing on the screen. So here's our display, and if you look at it, it looks like an X, Y coordinate system. And we have to figure out some things. First, we have to figure out what LED to light up, and we also have to find out what button was pressed and make sure that they align together. So how can we do that? Because we actually have some physical components that we have to work around, and there's actually some calculations that we have to figure out. So we have, I made a data array, and where this is the X and the Y location. But one of the issues that we have is when you program, it doesn't relate to the physical world. Because when you program, we have rows and columns right here. So rows and columns, in a data array, we start at 0, 0 for a 2D array, where the first one is the row, and then the column is the second one. So these are our rows, and it increases when it goes down. And the columns will increase the more you go to the right. But this kind of system, this programming idea, doesn't work for mathematics. Because normally when you look at a display or any kind of picture, you put X and Y in this direction. Okay, you have positive and Y. It's the inverse. In this case, the origin would have been at the very top, but we don't think like that. We normally think that the origin is at the bottom. And so what we have to do is make this into an XY Cartesian plane. And to do that, we would have to just do a quick calculation. It's actually not too hard in this situation. When it's 0, it's going to be 4, right? So you could have 4 minus the row. And therefore, when it's 0, it's going to be 4. Okay, so we can also do the same thing with the column as well. The column is actually the same as the X, because as we increase, we need to make a function that can convert from row, column, into the XY Cartesian plane. And so if you look at it, the columns correspond to the X. So we already know what that is going to be. The columns are going to be equal to X. So X is equal to columns. And the rows, if you want to, we just have to do this inverse function right here, is basically Y is going to be 4 minus the row number. So just doing that's just showing you how you can use some engineering thinking, because when we're programming, you also have to think about how you want to show your display. And all of these numbers are basically the LEDs that are lit up. When you first program, you also have to think about the physical components, because in here we have behind the display we have some resistors. In here we have our resistors, and we're actually pulling off, this was my original program, we're pulling off values to determine what button is pressed. And so I only need to use one resistor for 2 columns. okay? And this will actually give us, we actually have to do some calculations now because we're going to have two data sets. And so when I was programming this clock, I had two different arrays. And let me just go to the next slide. I had an array right here that corresponded to the buttons, because since the buttons were going in a zigzag pattern, you can see the buttons were going in a zigzag pattern. It was going 0, 9, 1 like this. Because I'm just using one resistor, and I have to determine now where that corresponds on my display. So this is my display here. And then these were at the very beginning, when you program, there are ways to simplify your code. But usually what I do is I program everything out, and then later I get it to work. And then after, so I got it working with 2D arrays. What I did is when a button was pressed, the dimensions were different. I just had it look through this table and find the corresponding LED. And then I would know what one was pressed, because there was a different mathematical calculation where if I pressed this button here, since it was in a zigzag pattern, different dimension, it tried to find it the corresponding number here. But obviously this system is not perfect, but that was how I built it. So I programmed it how I built it, and then later, after I got working, I came back and thought about it. I wanted to get rid of this information because all this is for my buttons, okay? And all this data is already in here, but this is how the button data is organized because the columns were linked together and in a zigzag pattern. And so I had to think about how can I, because when a button is pressed, it's going to give me, again, rows and columns, okay? And I also have to convert this so that I know that I want it to have 0, 0. If I press button 0, 0, it's going to be this one. But in my older original array, 0, 0 would be this button here. And so I had to figure out how can I go from here to change. Number one, I had to change the origin. Number two is I had to change the dimension size. This is a longer an array because I physically soldered the LED, the buttons in this kind of zigzag pattern, which was only using one analog read in an Arduino. So therefore, the data was going to be longer. So how can I go from this just to this? The idea is to eliminate all this information. And if you can eliminate that, your code is smaller. And if it's smaller, it can save space. It just makes your code a lot more efficient. To do that, we had to think about the mathematics to solve this problem. And since, let me go to show how I figured it out. So here are my buttons going in the zigzag pattern. All I have to do is separate, and you'll notice that these are in zigzag patterns right here. And this is my first, second, third, and so forth. And then this is the second row. This would be column 0, this would be column 1. And when I press a button, this is going to be row 0, and so on. And I need to convert this so that into X and Y coordinate system. 0, 0 is going to be the maximum height of my display, because this is at the top of my display. And so if my the number of LEDs I have in this case is 1, 2, 3, 4, 5. 5 LEDs, it's going to be your max rows, which is 5. And then for the Y, we can minus R, minus the row. Okay? And so when the row is 0, we can calculate the height. That's not a problem. Now, we have a problem for the X, because this is a graph. When X increases here, and then Y increases here. So to do the X, this would be like X0, and then this would be X1, this would be X2, and this would be X3. And these ones are in this zigzag pattern. And so we have to find out what's going on. Well, this is row 0, this is 0, this would be 0, this one's going to be 2, 4, 6, and this one's going to be 1, 3, 4, and then this will be 5. And so the relationship to determine the XY in this part is we have to first find out if the row output, the row number is an even or odd number. And you probably remember from programming class that you can mod it by 2, and that will determine the remainder. So if I divide these numbers by 2 and the result is 0, we know that we're on the even row. And if we're on the even row in that first data, we're on column 0. And if it's an odd number, if we modulate it, and if modulate is not equal to 0, when you divide these numbers by 2, then we are going to be the column plus 1. And basically we're linking 2 columns together in the same procedure. So basically the problem I had was I had 2 arrays. One was my button array, and it was different dimensions. And this was my display, and I wanted my buttons to match my display, so when I press on a button, it's going to light up that LED. And so I was able to think about it and figure it out. All you have to do is split this into that mathematical zigzag pattern, just modulate the row, and see if check it to see if it's 0. If it's 0, then it's an even row, okay? And so your X is going to be equal to 2 times the column number. And then to figure out the other one, if it's false, it's going to be the column plus 1. And then that will go through right here. You're still going to get the rows and columns, but I don't need to use this previous LED display for the buttons to figure out what LED corresponded to what button pressed. I was just able to do it with several lines of code, and then I also had to convert the rows column buttons into an XY. And so basically that's just finding your maximum height minus the row divided by 2, and I was able to determine the X and Y coordinate system. That's the idea about programming, and when you're building, sometimes you have to, you'll learn something new because you have these problems. That's why I like building things and programming and putting them together.
Thanks for watching this video. Hope it helped out. If you enjoy electronics or want to learn about how to fix electronics, consider subscribing, and I'll see you in the next video.